Okay, everybody, this is day 2 of square root functions, and today we are actually going to be looking at square root inequalities. Okay, so really the only difference here from everything from yesterday is now your graph's going to have to include some shading to represent your solution set. Okay, so notice the function here, I have f of x is greater than the square root of x plus 1 subtracted by 2. So I'm going to graph the function's curve first, and then I'm going to use a test point to determine should I shade above the curve or should I shade below the curve to give me my solution set. I start off the same way we did yesterday. We're going to focus on the radicand here. It's got to be a number that is not negative. So x plus 1 has to be greater than or equal to 0. That means the domain is going to be x is anything negative 1 or larger. Okay, and that negative 1 is the first value that I'm going to plug into the function. F of negative 1 would equal the square root of negative 1 plus 1 subtracted by 2. That's going to give me 0 minus 2 or negative 2. Okay, so we plot that point, negative 1, negative 2. All right, next number that I plug in is going to be 0. F of 0 equals the square root of 0 plus 1 subtracted by 2. Square root of 0 plus 1 is going to result in a 1. 1 subtracted by 2 is, of course, negative 1. Okay, and then I'll plug in a 3 next. F of 3 equals the square root of 3 plus 1 subtracted by 2, which is going to give me square root of 4 or 2, then 2 subtracted by 2 is 0. So we got 3, 0. And let's do one more for good measure. Let's plug in 8 for x. So f of 8 is the square root of 8 plus 1 subtracted by 2. Square root of 8 plus 1 would be square root of 9, which is 3. 3 subtracted by 2 is, of course, 1. All right, so we got plenty of points here to form the curve. Now notice we have to focus on the inequality symbol here. It is greater than, not greater than, or equal to. So that tells me that the points that are on my curve are not actually going to be part of the solution set. So I'm going to represent that by using a dashed curve here, not a solid curve. Okay. And then I've got to determine, should I shade above the curve or should I shade below it? All right. I will do that with a test point. You want to pick a curve or a point whose x coordinate is within the domain of the associated function, and that point's got to be either above your curve or below your curve. So I can get away with using the origin. Here's my test point. Okay. So the origin is right here above the curve, and it is, of course, got an x value that is within the domain. All right. So I'm going to test that by plugging them into the function. So I'll put in a 0 for f of x, which is like y is greater than the square root of 0 plus 1 subtracted by 2, or 0 is greater than or equal to the square root of 1 subtracted by 2, or 0 is greater than or equal to negative 1. That is a true statement, yes? So that tells me that this point of 0, 0 should be part of the solution set. Since it is above the curve, I will shade everywhere above. But you make sure you take the domain into account here, okay? So I'm going to actually use this tool right here, and I'm going to shade only this area, okay? Don't shade any part of the coordinate plane whose x-coordinates are not greater than or equal to -1. All right, and of course, the red shaded region is my solution set. All right, what does that make the range of this particular curve? Well, the shaded region is everything above the curve here, right? You cannot include the y-coordinate of the lowest point on this curve because those points are not actually part of the solution set. So this time I got to say my range would be y is greater than -2. You can't include -2 in this case. Okay. One more example. This time we're graphing f of x equals the square root of the negative square root of x minus 2 subtracted by 3. So we focus here first. That's got to be greater than or equal to 0. Of course, x is greater than or equal to 2. All right, now I'm not going to show quite as much work this time. I'm just going to plug the 2 in there. If I were to evaluate f of 2, that would result in -3 for y. Next value I would plug in would be 3. That's going to give me -4 for y. Let's see, then I'm going to plug in 6 next, right? Because 6 minus 2 is 4. The square root of 4 would be 2. Then you take the negative of that, which is -2, subtract it by 3, end up with -5. All right, and then we could do, it'll take us a little bit off the curve here, or off the graph, I should say, but we'll try 11 next. 11 minus 2 is 9, square root of 9 is 3. Take the negative of that, -3, -3 minus 3 is -6. So we'll just estimate the location of that right about there. Now notice your inequality symbol, it has the equal portion of it, right? Less than or equal to. So that means this curve is going to be solid. All of the points that are on this curve are part of the solution set. Okay? And then for my test point, you can't use the origin in this case. All right? The origin has an x-coordinate of 0, which doesn't fit within your domain. So you got to find something different. I'm going to use, let's do the point of 3, 0, which is above the curve, right? So if I plug that in, 0 for f of x, 3 for x, it's going to give me 0 is less than or equal to square root of 3 minus 2 would be 1. Take the negative of that. So 0 is less than or equal to -4, which is a false statement, correct? So that tells me this test point is not part of the solution set. Since it was above the curve, that means I should actually be shading the opposite region, which is below the curve. Okay? So that's going to look something like this. All right, and that's going to make the range y less than or equal to -3. Okay. All right, now we can check this with Desmos just like we did yesterday. So I'm going to click here, open it up one more time, start graphing. Let's go split screen here. Oops, sorry. All right, so the function, instead of f of x, I'll type in y less than or equal to the negative square root x minus 2. Right arrow to get out of the radical, subtracted by 3. Okay. And you can see my curve here. Move that over and we'll compare it to ours. You can see that we have the proper endpoint of positive 2, negative 3, and we got the proper shading below the curve. All right. Okay, so at this point, it's your turn to practice here. You're gonna move over to practice 2. Try that on your own, and when you're done, click at the bottom there to check your work.